Kia ora, Year 13. I'm going to start doing some stats videos over the next couple of days. This is a student request. Please just keep on emailing in any questions that you've got, but I thought I'd start with some of the old probability concepts exam questions. So in this one, I'm going to do question 2A from last year's paper, the part that's all about airport delays. I'm going to keep them reasonably short, so I'll be splitting it up into parts of questions. So this one starts out like this. We've been given data on all flights that departed from Wellington Airport during one day in January 2017. As usual with these questions, it's really important that you read that slowly because this is going to be a key part of the merit question in here. So we've got data on 83 flights, and we're told that for the 83 flights, 64 were done by Air New Zealand, 31 were delayed, and 12 were not Air New Zealand and were not delayed. So we've got to pick one of those flights at random and figure out the probability that this flight was delayed, given that the flight was not operated by Air New Zealand. So there are your keywords in there. As soon as you see that given that, you know that the first thing you've got to work out is a conditional probability. So it's given that it was not done by Air New Zealand, which I'll write as A dash. What are the chances that the flight was delayed? So I'm going to write that as D. Now, you can do this in several different ways. If you're in my class, you probably know that I'd prefer to do this with a table. That's partly because there's no sequencing in here. So there's no conditional probability stuff given to me up here. It's just some pretty straightforward category numbers. So when I do this, I'm going to set it up with a simple table that looks like this. The first thing I'm going to put in is that there were 83 flights altogether. We'll make this D and this D dash for not delayed. And this can be A and not A. Now, the first number that I was given, I think, was that 64 flights were operated by Air New Zealand. So we can put that in here. Straight away, we can work out this one. This will be 19 flights here. 31 of the flights were delayed. So we'll put 31 down here. And that means we've got 52 in here. All right, so we're just working with the column and row totals so far. Now let's go back up to the question because we need one bit of information from in here. So let's see which one we're given. Okay, so we've done that one, we've done that one, and that one. Just tick them off as you go. 12 flights were not operated by Air New Zealand and were not delayed. So we can pop 12 into this cell, and that means we can figure out the others. So 40 here, 24 here, and 7 here. Right, so what's the probability that this flight was delayed, given that the flight was not operated by Air New Zealand? I'm working with just those flights there, and 7 out of 19 were delayed. So do not write 7 out of 19, okay? We must give the probability as a fraction. So probability of delayed given not in New Zealand is equal to 7/19. Okay, so a pretty easy U question. You don't need to use the conditional probability formula for that, but I'm going to remind you what it is anyway. So to work out a conditional probability, what we're doing is we're limiting ourselves to the situations where the flights were not done by Air New Zealand. Right, so that's what this bottom line of the fraction represents, the denominator. And then we're saying out of those flights, how many were both delayed and not operated by Air New Zealand? You're given that formula, but you really need to know how to use it or it's not going to make any sense. So that was the achieve part. To get merit in this question, you had to answer that question. And then the next one, which is over here. Give 2 reasons why care should be taken when using this data to predict whether the next flight departing from Wellington Airport will be delayed. So there were a bunch of things that you could say here, but they all come down to this. So I'm going to do some notes here. No, I'm not. Where's it gone? Okay, so the first thing is that the sample, this is the big idea, and then we have to put it into context. The sample doesn't represent the population of all flights out of Wellington. Right, so that's the key idea, but that's not going to get you any points because it's not in context. So what do we mean? Well, the flights were all sampled on one day, right? So that means we might get a day of the week effect. Right, so what do we mean by that? Well, might be more flights on weekdays. So that would increase the probability of there being a delay. What's another thing that could happen? Well, the most obvious thing is that airport delays depend on the weather. So we don't know when in the year or which month, when in the year the sample was taken. So can't assume similar patterns between summer and winter. Right, so you'd expect to find more delays in winter than in summer, and we just don't know when this data was taken. The other thing that we don't know is we don't know the time of day. So this data, the 83 flights here, was collected over the course of one day, but if you read the question, we're asked why we have to be careful using it to predict the next flight departing, what the probability is of that being delayed. So the next flight departing will be happening at a certain time of day, and that will affect our probability. You might expect that early flights would have fewer delays on the one hand, because there'll be less built up delay in the air traffic system, but maybe fog is worse in the mornings. Okay, so writing down ideas like that link the idea that our survey doesn't represent the population of all flights out of Wellington very well. And you had to have two of those reasons, and then if you'd got that simple probability calculation right, you got a merit. Okay, on to the last question, which is, if you see it, a really, really easy excellence question. And I quite like it because you can do it using a table again. So we've told that we've got a probability model which has been developed for flights going from another airport, so nothing to do with the first data. We've got two events. A is the probability or the event that a flight's departure time is affected by passenger behaviour, and B is the event that a departure time is affected by weather conditions. And all we're told are two numbers. We're given this probability, A or B, and this one, not A or B. You can do this with a Venn diagram, but I like doing this kind of question with a table because we can set this up as follows. So we've got A and B. So here's A and here's not A. Here's B and not B. Now we know it all adds up to 1. The first number, 0.54, can be given by looking at what can we shade. So A or B is this cell, that's A and B, and this one, because A happens in both of those, and it's also this one here. Right, so they add up to 0.54. So let's just go over that a bit more slowly. This notation means A happens or B happens or both things happen. So in this cell, we've got B happening, but not A. So that's included. In this one, we've got both of them happening. So that's included in A or B. And in here, we've got A happening, but not B. So that's included. Now, if they all add up to 0.54, that means that this one is 0.46. Now we're going to do something similar with this one. Right, so same events. We've got B, not B, A, and not A. So not A or B is going to be here. That's the not A part, or B. So they add up to 0.86. And that means this one must be 0.14. So when you look at it like that, you can see pretty easily that the probability of B not happening is going to equal 0.46 plus 0.14, which is 0.6. And that means that the probability of B happening is 1 minus that, which is 0.4. Now let's look and check what we were asked for exactly. Okay, what's the probability that a flight's departure is affected by weather conditions? So we are asked to find P of B. Now actually, if I were a proper maths teacher, I would have gone over that at the start of the question, not the end, right? So that's what we're trying to find. What's the probability that the departure time is affected by weather conditions? So we're looking for P of B, and we've got it. right? So it's equal to 0.4. Notice that I can't get from that information the probability of A happening, but I've got just enough information to figure out the probability of B happening there. Okay, thanks for watching. That's plenty long enough. Leave me any comments or email me if you've got more questions that you'd like me to do. I'm only going to do the videos if people are watching them and if people are finding them useful. So please shoot through some feedback if you're in my class. Tell me what you'd like me to do next.